IP policy routing. What is IP policy routing? In short, you select some IP packets and routing those packets by a specific routing table. It can be done via border reshuffle confined routing. In Azblink border control system, you have three routing tables to manipulate: main, moon and star. The main routing table can be accessed via system network static routing. And usually, the routing tables moon and star are empty. In the case we discuss in the previous sections, we need to isolate some traffic and use a separate routing table to redirect the traffic. Hence, we will put the routing table moon into use to solve the issue. But what kind of traffic needs to be selected to look up the routing table moon? Our target is, traffic from Eth5 destined for an internet host will go out from Eth3. Thus, we put the subnet where Eth3 is sitting into account. Navigate via border reshuffle confined routing and fill as follows: to/from, to subnet, 10.1.1.0/24, subnet of Eth3, routing table, moon. After pressing add button, look at the right portion of the screen. So, traffic with destination 10.1.1.0/24 will look up the table moon. However, this is not enough. The traffic to/from Eth3 and Eth5 should be taken into account as well. Then, we have, to/from subnet, 10.1.1.0/24 routing table, moon and the subnet where Eth5 is sitting, 172.16.14.0/24 to/from, to subnet, 172.16.14.0/24 routing table, moon and to/from subnet, 172.16.14.0/24 routing table, moon. After finishing those settings, the first list box on the right will display the rules in order. Each packet will be examined from the first rule to the last rule and routing decision will be made accordingly. Up to this moment, we select some types of traffic and send them to look up the routing table moon. But our routing table moon does not have anything yet. We start adding something. First, the default gateway from second ISP is added. Default gateway, 10.1.1.11, net, interface, Eth3 routing table, moon. Second, the routes to the subnets to Eth3 and Eth5 with respective IP addresses as gateway, subnet, 10.1.1.0/24 IP address, 10.1.1.31 Ethernet interface, Eth3 routing table, moon. The following is for Eth5, subnet, 172.16.14.0/24 IP address, 172.16.14.1 Ethernet interface, Eth5 routing table, moon. Reboot the system and put a machine into 172.16.14.0/24 connecting to Eth5 to see if the packets can go out from Eth3 with source IP address 10.1.1.31. It should work as expected. Let's go back to the rule listing. The packets will look up routing table moon or main according to the rule table. However, once looking up the routing table moon, the packets will go out directly because we have default gateway in the routing table moon. Thus, if you wish traffic from Eth3, LOC, would go to elsewhere, Eth1, Eth2, Eth4, you should add those subnets into the routing table moon. IP load balance. Assume we have three servers with identical data to perform identical functionalities behind the border controller. To make the example easy to understand, let's say that they are taking HTTP form input to perform search and display the search result back to the users. Since the three servers are with private IP addresses, they cannot be accessed directly from the internet. Thus, doing load balance in DNS level is not possible. To allow the access to the server behind border controller from the internet, port forwarding can be used as we mentioned in the previous sections. But port forwarding can only forward the traffic to one server behind the border controller given the condition of one public IP address, and one TCP port. This is not what we want. What we want is the service requests can be distributed to the three servers. In this case, we turn to the help from border rule IP load balance. We create a service item for the traffic with destination IP address 192.168.11.200, TCP port 80 on the left portion of the screen, service IP address 192.168.11.200 protocol, TCP port number 80 and press add button. After pressing add button, we will see a service item shown in the window below. For each service item, we can add several servers into it for load balancing. Please note that the distribution will be performed in a round-robin way, denoted as RR, to all the servers within that service item. For the requests issued from the client, S, coming from the same IP address, they will be persistently sent to the same server if the requests arrive in 300 seconds. This avoids the broken session problems between the client and server. How to add the servers 172.16.11.31, 172.16.11.32, and 172.16.11.33 into a service item, and the service requests will be distributed to the three servers in a round-robin way. On the right portion of the screen, you can have the following setting: service IP address, 192.168.11.200 protocol, TCP port number, 80 real server IP address, 172.16.11.31 service IP address, 192.168.11.200 protocol, TCP port number, 80 real server IP address, 172.16.11.32 service IP address, 192.168.11.200 protocol, TCP port number, 80 real server IP address, 172.16.11.33. Web Application Firewall. Note, the function is removed both in VED and WED, it only exists in early versions of VED. The border controller can be deployed as a reverse proxy to filter some unwanted service requests from website. The border controller is acting like a web server to the people in the internet by accepting the service requests from the internet and sends the requests to the real web server inside its LAN. And it can be configured via border web reverse proxy, request host, www.doga.com destination, http://172.16.9.32. And if you want to filter out some service requests containing some keywords in the submitted forms, you can specify those keywords at border web request filter, for example, keyword, admin. If we do not want the requests containing the keywords admin in the submitted form, we can enter as above and press add button. It will be put into effect after rebooting the server. However, it shall be used very carefully. The web server on the port 8082 will be also affected. If you block the keyword admin, that implies you cannot use admin to log into the system. Usually, it is used to block web attacks on the security holes of some specific web applications. You need to examine the log files to find out the proper approach for filtering those malicious requests. IP Masquerade. IP Masquerade is to describe the scenario when the packets sent from local area network pass the border controller to the internet. Their source IP addresses, with private IP addresses, will be changed to the public IP address of the border controller in those packets. This is automatically done when you use the system as long as the border control is turned on. You do not need to set up anything special here in border rule IP Masquerade. The function here is used when you have multiple IP addresses set on the interface eth0.1 port, and you would like to have outbound traffic look like from different IP addresses. Then, you set a range of IP addresses here, for example, IP address or a range of IP addresses used by SNAT, 61.2.3.161.2.3.20.